My value listener, Solution Nuggets aims at equipping science and mathematics scholars with the desired skills in CBC and the IGCSE, an international curriculum. The subject matter will be uploaded on regular basis in a series of units. To remain updated through notifications, kindly subscribe to this important channel and share with friends. Our today's unit is on static electricity. Static electricity is a form of stationary charges, meaning charges that are not flowing, and that one will be experimented through this. Have you ever tried to rub a ruler against your head and observed its effect on small pieces of paper? What I mean by this is you take your ruler, rub against your hair, then cut small pieces of paper and try to bring the ruler closer to the small pieces of paper. From that, our unit will be well understood. We are also going to explain how static charges are likely to affect petroleum transporting tankers if they are not fitted with a long chain that touches the ground to earth the developing charges. What is likely to happen? Then ask yourself these other questions. Why do our shoes get more dusty after polishing them for a long period of time? Why do woolen or nylon sweaters produce sparks at night? To understand that subject matter, we have to understand static electricity. Objects made of materials such as plastic, ebony, and glass form static charges on their surfaces. Charges in them do not flow. Now, how are static charges produced? One method is by rubbing. Next method is through induction. We are going to look at charging by rubbing. Here is a neutral object that has equal number of positive and negatives. If you happen to rub it against another material, a non-conductor also, a poor conductor of electricity, you rub, as you can see, the object gets charged, as you can see in object number 3. That process of charging is known as charging by rubbing. The charges acquired are known as static charges. A balloon acquires different charge when charged using a different material. Now this time we are rubbing using a different material. We are going through the same process. Because of the change of material, the object acquires a positive charge. What is charging by induction? Charging by induction, you need a neutral object, as you can see it here, with equal number of positives and negatives. That one is said to, the object is said to be at neutral charge. You bring in a charged object, as you can see. Look at that. So what happens? All the negatives are repelled because the charged object has a negative charge. So it repels all the negative charges to the left, and all the positive charges were attracted, because positive charges are always attracted to negative charges and vice versa. But for the negative charges, because they are similar charges, they repel. Then on the negative side, you fix an earth rod which will force the negative charges to be attracted to the positive charges in the ground, and the negative charges will flow through the earth rod to the ground. The object remained positively charged without rubbing or contact. The charged material used is known as inductor, and therefore that the method is known as induction. If you repeat the same exercise, after that you eliminate the earth rod. After repeating the same exercise, now with a positive charge, the opposite will happen. In summary, when positive charges are brought closer to each other, they attract. The positives repel, the negatives repel. Therefore, like charges attract, like charges repel, like charges repel. If an object loses negative charges, as you saw it losing through the earth rod, it becomes positively charged. If an object gains negative charges, it becomes negatively charged. A charged object can attract an uncharged object. As I said, if you happen to polish a shoe, the shoe acquires a charge and the dust is not charged. Therefore, a charged object will always attract an uncharged object. The dust will be attracted to the shoe. When two objects with similar charges are brought closer to each other, because of the similarity of the charges, repulsion will occur, as you have seen. And when objects with opposite charges are brought closer to each other, then attraction occurs. Here is a good description. What is likely to happen if these two balloons are brought closer to each other? Look at them. Both of them were charged. They were rubbed using same material, and therefore they acquired the same charge. If they are brought closer to each other, they are likely to repel. What about this one, where you have the negatives and positive? If you bring these balloons closer to each other, there's a positive charge balloon and a negative charge balloon. If they are brought closer to each other, they attract, because unlike charges attract. Precautions. Some internal parts of electronic devices, such as television, radio players, radio and photocopiers, they use electricity, and in the process, in the screen, electrons flow at a very high speed, therefore accumulating a lot of static electric charge when in use. These charges remain on that surface for quite some time, and that's why even if the device is disconnected, if you happen to touch the screen, there is an effect you experience. Therefore, we are always advised, do not touch the inner parts of such devices immediately after it has been disconnected from the electricity, because that one can lead to shock. Then clothes made of certain materials such as wool, nylon produce a lot of static charges as they rub on the body. These charges can cause minor electric shock, especially when we touch a metallic surface, because the metallic surface attracts charges from the ground. Wear woolen clothing on top of cotton fabric, different materials, so that each will produce its own charge, and because they are different materials, those two charges will cancel to neutral. So this prevents production of the static charges. But if you wear one type of cloth without covering it with another one, automatically you experience the static electric charges. Application of static electricity in our day-to-day life. On a rainy day, clouds rub against the air, or there is friction between the clouds and the air, and therefore they acquire some charges, as you can see. Then when the charges accumulate, they attract negative charges to the ground, and after a short while, lightning occurs. And therefore, we are always advised that on a rainy day, not supposed to shelter under the tallest object. It is able to transmit the opposite charges from the ground at a faster rate to the charged cloud. So safety measures: never seek shelter under an isolated tree. Do not walk in flowing water during lightning and thunderstorm. Do not lean on concrete or metallic walls during thunderstorm, because do not carry metallic objects such as spades, rakes, any metallic thing during thunderstorm. Do not ride bicycles, motorcycles during thunderstorms. Unplug electrical appliances such as phones, television and radios from electricity sockets during thunderstorm. Do not use an umbrella during thunderstorm. Look at those three. The first lady here is leaning on a concrete wall. So application. Some printers use a fine powder. Once the toner is fitted inside there, as you can see, the static charges formed attract the toner, the powder in that thing. Then once it is attracted as per the words formed, or the letters formed through the printing, and therefore that's how a document is produced. That's the first application of static electricity. In the spray printer, the one that uses colors, the paint also acquires a static electric charge inside the spray gun. Then the particles also are spread by the static charges as per the printout or as per the typed letters. So as the paint is pushed out of the spray, repulsion between the paint particles make them spread. And therefore we have electrostatic charges in use in a printer that uses toner and the spray printer that uses ink, the inkjet. How do we control air pollution? Smoke polluted gases pass through a chimney, as you can see. The chimney contains static charges. Therefore, the charges make the smoke particles to stick because they are attracted into the inner surface of the chimney, where they are removed later. Chimneys can be fitted with a static electricity and used to clean the air. Current electricity is a form of electricity that flows now. The other one was stationary charges, but once they accumulate, they can flow. So this one, current electricity, is a form of electricity that keeps on flowing because there are charges inside a conductor. They keep on flowing. They flow through conductors. And for the charges to flow, there must be a source. The source is the generator of the charges. Where are the charges coming from so that they can keep flowing? One source is the car batteries, the dry cells, the solar panels, and generators. A generator is any device that is rotated to generate power. For example, this one is a bicycle dynamo. You have to keep adjusting this knob through riding. The rubber rubs against that knob to produce electricity. That's the smallest generator we can have. There are big generators. Some are driven by petrol or diesel, therefore they are known as diesel driven generators. We have the wind turbines, the geothermals, and let us look at some of the examples. Here is this one is a dry cell. These are the dry cells, the car battery, bicycle dynamo, the
energy created by the water that the dam holds back. They capture the energy of the water as it falls from high up behind a dam. This is done through the use of turbine generators,
aligned with their rotor on a vertical axis or a horizontal axis. Vertical blades can pick up wind coming from any direction, but with much less efficiency than horizontal axis rotors. Today,
now the other form of current electricity is the geothermal. As you can see, this is energy tapped from underground steam. The steam is used to drive large. Then let us now look at simple circuits. How do we connect circuits? An electrical circuit is a closed path of connection between a source of electricity and the electrical components. Which are these components? One, the connecting wires. These are used to connect different parts of the circuit. These ones, we call them the connecting wires or the connecting cables. We also have the dry cell, which act as a source of electricity. Remember, we are preparing a simple circuit. Those ones are the dry cells and the cable also. We also have got the torch bulb, which shows whether the electricity is flowing by turning on or off. That one, and the cable also. We have an ammeter, which is used to measure the amount of current flowing in a circuit. That one is the ammeter. We also have got a voltmeter, which measures the quantity of charge, the voltage that is making the electricity flow. How much charge is in the source. That's what we call a voltmeter. Then, what is the procedure of connecting a simple circuit? This is where we start. Take the dry cells, fix the voltmeter, the ammeter in position. Then connect the positive terminals to the bulb, the negative terminals to the bulb without a switch. Connect the voltmeter. The negative side is black and the red one is positive. Connect to the positive side, and because a voltmeter measures the voltage, that's why I have connected it to the source to check the quantity of charge the dry cells are releasing. We have two red knobs. The middle one, this one, is used with batteries that have low voltage. Then this one is used with dry cells that have more voltage. Because these are two dry cells, they have a maximum of, each has a maximum of 1.5 and therefore in total 3.5 volts. That's why we have connected to the next knob. Then from there we connect the ammeter, the negative side and the other side, and because the current we're expecting it to be more, we have connected to the same way to the second knob. An ammeter is always connected to the device that is consuming the electricity produced by the dry cell. If you look at the connection, the ammeter is fixed next to the electrical device. Once you close the switch, the bulb goes on, as you can see, and once you disconnect, the bulb goes off. You switch it on once again, you close the gap, it goes on and off. Therefore, we look at, let us explore different types of bulbs connections and their advantages. There are several ways of connecting bulbs. We have a method known as parallel bulb connection, and we have a series bulb connection. And what makes the difference? Let us start with a parallel bulb connection. You take the dry cells, have two bulbs, fix the negative side as you can see, fix the positive side without the switch, fix the voltmeter and the ammeter for each bulb, then from there close the switch. You notice that the two bulbs goes on, and there is a unique thing with this connection. There are several paths. For example, this bulb has got its own path from the source of electricity. This one has got its own path from the source of electricity. Each bulb has got its own path. Therefore, if one bulb gets damaged or if it blows, as you can see, it does not affect the other one. This is the best way of connecting bulbs. This is known as parallel bulb connection, where each bulb follows each bulb has got its own electrical path. When one bulb goes off, it does not affect the other one. Number two, each bulb receives the same quantity of charge. Therefore, the bulb light the same way. They do not, one bulb does not light brighter than the other one. The two bulbs produce the same quantity of light if you look at them. That is known as parallel bulb connection. It is the one that is used to install electrical bulbs in our houses. We also have got the second method known as the series bulb connection, where the two bulbs share the same path of electricity of charge. So that's the first connection. We have connected the path. We are about to switch on the connection. The bulbs are sharing the same path. So once you close the switch, the bulbs go on. And in case one of the bulbs goes off or blows out, it affects the other bulb too, because the electricity, the flow of charges is passing through the first bulb to the other one. So in case one bulb goes off, it affects the other bulb. This is the worst connection that you can ever have in a house, because in case one bulb goes off, all the bulbs in the house will go off. This type of connection is known as series bulb connection. It is not the best. Number one, the bulb do not light the same way. The bulb closer to the dry cells lights brighter than the bulb away from the dry cells, or depending with the wattage of the bulb. So we look at now, did you know that there are also other two ways of connecting dry cells, namely the same parallel dry cell connection and series dry cell connection? What makes the difference? In parallel connection, all the cells are connected, the same terminal is connected to all other terminals. As you can see, we'll have the positive connected to a positive, then to the negative to the negative, then the the negative to the one side of the bulb and positive to the other side. Then you leave a gap for the switch. If you happen to switch on the right, the switch, the bulb lights. But it is quite unfortunate that there are two cells in use, but the most unfortunate part is that this type of connection, this type of parallel cell dry cell connection ensures that only one cell is in use. The other one is not in use at all. So this bulb is lighting at under 1.5 volts. If you happen to add another cell, the lighting does not change, because this type of connection fully depends on one cell. So the other two cells are not important in the connection. So we advise that this is not the best way to connect dry cells, because which is the best connection? We have a series connection that looks this way, where you take two dry cells. The positive connects to the negative, and if you happen to fix this and switch it on, that is, it brightens, it lights more, because this bulb is using two dry cells. If you happen to switch it off and add more cells and fix the same, the bulb becomes more bright, meaning now the bulb is under 4. The first time it was under 3.0 volts, now it is under 4.5. The more dry cells you add, the brighter it becomes for the bulb. Therefore, what in summary, two or more dry cells can be arranged in series or parallel. When the dry cells are arranged in series, the positive terminal of one cell is connected to the negative terminal of the next one. When the dry cells are arranged in parallel, the positive terminals are connected together and the negative terminals are connected together. The bulb is bright when the dry cells are arranged in series than when a similar number of cells are arranged in parallel. We have come to the end of series 1, unit on electricity. Remember, more series are coming. Remain tuned through subscription and you'll be notified once a video is released.